Hi, I'm John Paulraj, and on this particular video, we're continuing to solve the IB/MAI Mathematics Applications and Interpretations for the HL Time Zone 1, Paper 1. This is part 5 for HL students. Let's go. All right, then let's go to the next question, question number 5. All right, this is a trig question, looks like it. Tiki is sailing a boat in the ocean for the first part of a trip. She plans to start at point A and travel to point B. She then plans to turn and travel 13 kilometers on a bearing of 100. I hope you recall all the definitions of bearing. Okay, if not, please go and revise and review those things. You can come back to this video a little later on. Okay, of 100 degrees to point C as shown in the diagram. So basically she's starting from A, she goes to B, and that's the bearing. Okay, from the north the angle is measured, and then she's turning around here to that point C. That's what's given in the situation. Due to navigational error in the first part of the trip, Tiki arrives at point D instead of point B. So instead of reaching here, she's reached that point D. Point D is 2 kilometers due west. Now that phrase, due west, in trig you'll come across this phrase. What does that word due west mean? I'll explain that when you come to that, but that's an important phrase I've highlighted so that I don't forget, okay? How to interpret that in our problem solving. Okay, point D is due west of point B, all right, and is 2 kilometers. I'll explain that right now. Okay, so it literally means that this is at 90 degrees, almost like saying these both angles, this angle and this angle, both at 90 degrees. That's the area due west. So if you just draw your directions, if you remember, you know, something like x-axis, y-axis, okay, so you know this is due west, this is your west, and this is your east, okay, and this is at 90 degrees. So whenever you see due west or due north or due south or something like that, remember it's almost like saying that it is, you know, perpendicular, right? So that's the way to interpret that phrase. So literally it's saying that, you know, B and D are on the same plane, 90 degrees, okay, perpendicular. Keep that in mind. I hope that makes sense. All right, what are we saying here? They have asked us determine the distance from D to point C, because she's ended up at D. All right, so I'm just going to erase my annotations. And what are we looking for? We're looking for this one, D to C, D to C. There you go. That's the triangle DBC we're looking for, okay? And the distance DC in that triangle DBC. So what do we need here? We are given DB, all right? We are given BC, all right? We want to find out DC, and what do? We can use cosine rule, okay? Cosine rule, but we need this particular angle inside. We need this particular angle inside. So how do we make use of that concept due west? Now, if you can see this angle, the bearing is 100. This is a 90 degrees. So total angle around that point B should be 360. So it's basically 100 plus 90, and so that this angle, the angle B inside the triangle, okay, so you have the triangle DBC. Let me just make that rough sketch here there. Okay, so if this is my point B, this is my point B, right? Yeah, B. So D should be a little north. Okay, let me see if I can do a better job with that. That's my B, that's my D, all right, and the point C is somewhere there. So this angle is basically, you know, around that point B, totally should be 360. So 360 minus the 100 plus 90. Okay, I hope that made sense. And can you see what I've written? Okay, there you go. You can see that 100 plus 90. That 90 is from this angle, okay? This is my 90 out here, and that's the bearing out 100. That's the bearing 100. I hope this is clear, okay? That's the bearing 100, that's the 90, and so this particular angle is just 360 minus 190, okay? That is what we need before we use something like cosine rule. So 360 minus 190, let's just use the calculator, why not, okay? So here we go, and again, let's just insert a new problem, and a calculator, and 360 minus 190, what do we get? We have 170. Let's come back. So I'm just going to write here, angle DBC is 170 degrees, okay? 170, is that right? Okay, 170 as we mentioned here. And then we can say using cosine rule in that triangle Okay, make sure you write down everything clearly, you know, in which triangle you're using cosine rule. So what's the angle opposite to that DBC? That's the side that we're looking for. We're looking for D to C, right? That's the distance they want. So DC square equals, I think that distance is 2, right? 2 square plus 13 square plus a 13 square minus a 2 times 13 times cos of that angle DBC. All right, now this is what is expected in the IB. Make sure you show your substitutions, okay? That is important, not just because they give you the formula booklet. This formula is probably there in the formula booklet, but you know, they're not testing whether you remember the formula, but they're seeing how you can apply the formula and know what value to substitute where. So I'm just going to write it as it is, and then we'll use our magical calculator. Okay, so 13, and this is cos of the angle 170. This is the formula for DC, but you know what, sorry, DC square, but then you can say that DC is basically the square root. You can actually do that. 2 square 13 square minus 2 13, and as I have shown you in the earlier videos, let's write that clearly, 170. As I've shown in the early videos, you can enter the expression as it is on your T and SPI if you're using, all right? You don't have to, you know, do that and then find the square root. Just as you see, this is your DC, right? And so we jump onto our calculator. This is the same problem, so we're going to continue right here, and we're going to insert the template for the square root sign, which can be found. You can go to the templates key here and find that, okay? So that's here. This one, all right, this one. If you don't want that, then you can just come here and, you know, just the control and the key above x square, or the key x square, okay, the control with x square will give the square root. Check that out. So this one, if you don't know where that is, as I said, you can go to the templates key, you can find all the templates. Okay, there it is. All right, so here I enter the expression as it is. So this is 2 square plus 13 square minus 2 times, don't forget the multiplication sign, times 2 times 13 again, and cos of the angle. Now I just happen to notice the calculator set to radians, but don't worry, we'll have to change that quickly. Trig cos of the angle 170. All these things matter, okay? And I'm glad, you know, so many errors are happening, not just errors, but you know, these situations are happening which can happen at the time of the exam. And you know, with the time ticking and that kind of environment, exam environment, you know, we can make a lot of mistakes. So quickly, if you can just press that and it'll shift 2 degrees. Can you see that? Just toggle, it's a toggle. But that's something to always check when you're doing questions like these. And when I hit enter, I think it'll give me an exact value because I didn't change that setting. Let me just go and check that again, all right? So yeah, it's an exact mode. So let's just go to approximate. Okay, and I hit enter, and now when I hit enter, it will give me 15. All right, it'll give me 15. So coming back to our notes page here, and that is a 15. Is that a meter? What is the units there? It is kilometers. Okay, good. I noticed that. Wow, so many things are happening in this particular video. But it's good for you to see that, okay? We all make mistakes, but how to avoid, I think that maybe is a bigger lesson here. How to check at every step. I'm not saying just making the mistake, but how to check at every step, and including something that we just saw here, you know, about the calculator, you know, keeping every calculations on the problem page. Even, you know, I just wrote meter because, you know, so often we just tend to think that distance means meters, but then even though I wrote meters, I went back to the question to check, is it meters? So good to have that kind of a habit. All right, this is part 1. And let's look at part 2. Part 2 says the bearing Tiki must use. We are finding out the bearing Tiki must use to travel directly from D to C. From D to C. So that means, remember, bearing is measured from the north. From the north at D, this is the angle they are asking us. Directly from D to C. What is the bearing? Okay, so you can write that thing down in the exact phrase. Okay, so bearing from D to C. And if you want, I think it'll be a good idea to draw. Okay, so because you know what, all these things, so there's the north, please mark the north, and you can mark that as, you know, and you can put towards C, and there you can mark the angle, you know, because all this, you know, visually if you represent marks, it counts as working. Now that's the angle we're looking for. And to calculate that angle, remember I said something at the start, that word due west. Where's that word? Due west. Okay, that means those two angles are 90 degrees, right? That's 90. So which means you're going to add 90 This one, let me indicate another color so that stands out. That angle is 90. The angle inside the triangle, let's put that with, this is what we are going to determine. You're going to add 90 to that angle, and then you'll find the bearing. That would be the bearing, okay? Now this one is towards, so they can, this is towards the point B, okay? All right, and I think this one was 2 units or something like that. So we could use sine rule or cosine rule to find the angle inside the triangle, okay? Inside it. Let's do sine rule. You could use sine or cosine, but let's use sine rule to find that angle, and the angle is BDC. The angle is BDC. All right, so you can write down with the phrase, is a space? Oh, not again. Okay, fine. I'm just going to continue here, okay? This is B part 2, and I'll just write using sine rule. If you notice, I'm writing down every word. Why? Because I want you to get in the habit also, okay? In triangle DBC, and you can write down sine of the angle, which is BDC, sine of the angle BDC, because that's what we're looking for, right? Sine of the angle BDC over the side opposite to that angle, BDC, the side opposite to that is 13. That's 13 should be equal to the sine of, we just found a DC, right? Let's look at the sine of the angle DBC, all right? DBC equals sine of the angle DBC over the side that we just found out was 15, is that right? 15, yeah. 15. Okay, which means the required angle, the sine of BDC, is nothing but 13 times sine of the angle DBC, sine of DBC. I think, was it 170? Yeah, 170. Sine of 170 over 15. And show this as working, but I'm trying to show you a technique how to use the calculator, because what happens is sometimes kids are switching every time, you know, oh, we saw sine on, I need to use my calculator now. Just wait, you know, work out everything, and then you can say therefore angle BDC is nothing but the sine inverse of that entire term. Now this approach basically, you know, kind of helps to, you know, minimize the use of the calculator, because, you know, even the calculator is taking some time, meaning you'll take some time to punch the keys, right? Every time you're switching, and then, you know, there's a disconnect. But with this technique, with this strategy, let me know in the comments, okay, how you feel about this particular strategy. I think every working wants to show, and then when you come to a stage that, okay, now let me, you know, use the calculator, because as we've seen, you can punch in the entire expression as it is, and I'm going to show that in a minute, as it is, and it'll give you the answer, all right? So let's do that. And so this expression as it is, I'm going to punch in. So here we go. This is my calculator again. I need sine inverse, and to do that, we just go here, and we can find the sine inverse, and I need the fraction, the template for the fraction is that, okay? And I'll type in as I have, okay, so 13 times the sine of 170, the whole thing divided by 15, okay? I have, can you see that? I have entered the expression as it is. Otherwise, you know, finding the sine, then writing it down. And then the other thing is that it also compounds the error of rounding off, because you'll find, you know, sine of 170, what if it's, you know, something that needs to be rounded off. Okay, let's just make sure it's in degrees, and now when you hit enter, you get 8.66, okay? Let me see, that's, you know, yeah, 8.66, and then it's rounded off to 2 significant figures. That's okay, we can write down to 8.66. This is the angle inside. This is the angle inside, and remember 8.6 is a small angle, and it's in degrees, don't forget that, okay? This is the angle inside, but we're looking for the bearing, and as I said, we need to add 90 to it, okay? So then we say bearing, again, if you want, you can write down bearing, okay? If you want, you can put this thing here. This is 8.66 degrees, and then you can say bearing of, let's use the same color, of C from D. That's the language. It's bearing of C from D. Bearing of C from D. And if you are afraid that you'll mess up in the language of the bearing, okay, bearing from D to C, right? Bearing from D to C. That's the idea, from D to C. And now I've written bearing of C from D, the same idea. But if you're confused, here's a tip, okay? Another examination tip. Just write down required bearing. No one can argue about that, right? If you're confused about that, just write down required bearing. So I just put that thing down here, required bearing. Meaning, what's the bearing that you required? I'm going to put it down. And that is basically to add 90 to what you found before, 8.66, all right? And that works out to 98.66. Now, angles have to be reported in one decimal place. That's an IB rule, okay? Money, anything to do with finances, 2 decimal places, and all other answers 3 SF unless and otherwise specified, because you're AI, they can test you with 5 decimal places. But typically, angles have to be reported in 1 decimal place. So we are going to write it as 98.7. Now, something about bearings. Typically, angles 1 decimal place. Bearings, these numbers before the decimal place should be 3-digit, okay? So since there's no third digit, a bearing typically is reported as 098.7. Now, we're not talking about bearings. So at some other stage, or if you have a question, do mention in the comments why that's 098, and I'll be happy to make a video on bearings and why that's 098, okay? 3-digit, that's the typical notation for the bearing. All right, what part was that? What part was that, and where are we? This is the bearing, this is A part 2. Now we're coming to B. Wait a second, I made another mistake. I made so many mistakes in this video, and I'm going to keep the mistakes because I don't know, I'm not even taking the exam and I'm making so many mistakes. But this mistake right now is in labeling the question. Did you notice I wrote B here, and actually that was A part 2. So I'm going to make the change. At every question, please check that way. Just don't rush to the next question, okay? I think that is maybe the most important thing to learn from. This is my A part 2, bearing from D to C. This was my... What was this then? Oh, this was part of that answer. This was part of the answer. Okay, so I can just write down what I should have written here, continuing. Okay, so I can say A part 2 continued. So if you're writing in a different paper, again another tip, you can write down what that was, A part 2 continued. If you're finding the bearing, so there you go, you use a sine rule to do that. So I've made several errors, and I'm going to keep this video as it is so that there's something that we all can learn from each other's mistakes. But as I have been trying to help and point out tips, and remember these mistakes were not intentional, actually happened, okay? But I'm glad that I was able to point out and help you. So I'm going to keep this video as it is with all the errors that I've made, so that you get an idea of everyone can make mistakes, so how you should then prepare. All right, we're getting too far in this video. A part 2, too long in this video I meant. So part B, let's try and knock it off quickly. Due to navigational error again. Oh, this question is all about errors. Is that what's having an effect on me? There was an error earlier, now there's another error. Now I've made several errors. Good, this is a great question. Due to navigational error in the second part of the trip, Tiki arrives at point E. All right, so now she's arriving here. He or she is arriving here instead of point C. So earlier there was a navigational error. That means, instead of going to B, he ended up at D. I'm assuming he, all right, whatever that is. The person arrived at D. Now instead of arriving at C, the person arrives at point E instead. Just write down the distance between D and the point E, justify your answer. Point E is 2 kilometers due west. Now I already explained that due west, what that means. Okay, so let's just go and clean this thing up a little bit so that you can see it better. Instead of arriving at C, remember the distance is what we found out, D to C. Due to another navigational error, she or he has arrived at E instead, and that's another 2 kilometers due west of the point C. Write down the distance between D and E. Now, this is just 2 points, so that should give you a hint that this might not be, such a lot. Now, what do we know? Due west, that means this is also 90 degrees, right? This, again, we said there was due west, and it's 2 kilometers here, 2 kilometers here, right? This must be a parallelogram. This must be the parallelogram, because, you know what? If I mark that DE, because that's what they asked, right? They asked, write down the distance between points D and E. This must be a parallelogram. Why should it be a parallelogram? Because the opposite sides, okay? The opposite sides, DB, can you see that? DB and EC. The opposite sides are not just equal, but they're parallel. And how can we say that they're parallel? Is because of the 90-degree thing, that due west that we just saw. So when opposite sides of a four-sided figure are parallel and equal, not just parallel, parallel and equal must be a parallelogram, which means then DE must also be 13. We got to write it down. So even though the video is going a little longer than usual, than expected, we're still going to write it down. So I'm going to write it here. Okay, this is part B. This time I can safely say so, right? That's part B, yeah. Part B, and we say that DE, was that the, check it again. You can see from how I'm doing it, DE. Check it again before you write, okay? These small things matter. DE must be equal to 13 kilometers what is the justify answer? The distance between D and E is 13 kilometers because DBCE is a parallelogram, because as DBCE in that order is a parallelogram. I think even if you write parallelogram, that's fine, but if you want to justify, I'm just wanting to make sure that I labeled it correctly. DBCE, did I write that? DBCE is a parallelogram, and then if you want to justify how you made out that it's a parallelogram, how did you deduce that it's a parallelogram, you can say the opposite sides, which two opposite sides? BD and CE, I believe, are parallel and equal, and therefore that justifies that DE must be equal to 13 kilometers. So that's all the time that we have for this particular video. If you found anything useful, please don't forget to like and share this video with your friends and subscribe to my channel. If you visit my channel, you'll find several other videos there. Do check them out. And if you have any questions or any concept, a topic that you want explained, to mention that in the comments and I'll make a video for you. See you in the next one.